Okay, for this screencast, we are going to do polynomial interpolation. Alright? Now, the example problem that I've done in class is trying to estimate log 10 of 10. Now, we know that the analytical solution is just equal to 1. Analytical solution. And the problem, the given data points is x, or 8, 9, and 11, and y is obviously just the log 10 of 10. I'm going to go ahead and make a figure and plot x and y in blue stars. Alright, so then there we go. So I've got, that doesn't look right at all. Oh, log 10 of x. And let me throw a clear, a CLC, and a close all. And I'm going to go ahead and throw a grid and a hold just for later. Alright, so there we go. So there's my 3 data points. I've got one down here, 0.9, 0.95-ish, and then I've got like 1.04. Alright, and then I want to make a polynomial that's going to fit these 3 data points and then solve for, or get an estimate of 10. Now, here's my polynomial fit. Now I have 3 data points, so I can only solve for 3 coefficients. So when I write my polynomial, y estimate, y equals a0 plus a1 times x minus x0 plus a2 times x minus x0. Let me make these capital for consistency. And yeah. And make that capital as well. When I have there, I have to, and this is squared, I have to stop here, right? My coefficients, my unknowns are a0, a1, and a2. So I have 3 unknowns and 3 data points. But notice that this polynomial is second order. Right? So I have 3 data points, 3 coefficients, but the polynomial is second order. So to fit that, I need to get my equations into y equals h times a, where a is a0, a1, a2, and then y is y1, y2, y3. And we've done this a million times before in the least squares regression. So I already have y is defined up here. So that means that I need to make h. So h is going to be the coefficients in front of a0, which is just 1's length of y, comma 1. The second column is going to be x minus x0. And then the last column is x minus x0 squared. And I need to put a dot in there. And then I also need to choose an expansion point. Now, if we go up here, I'm trying to estimate a log of 10. So 9 and 11 are the closest data points to 10. So I'm going to say that my expansion point is 9. And then that way, I can generate my H matrix. Finally, we use Carl Gauss's magical equation, and we get A star is inverse H transpose times H transpose times Y. And then I want to check it, so I'm going to compute Y tilde. Y tilde is H times A star. And then I'm going to plot x comma y tilde in red. And when I pull up the graph, there we go. I've got my second order polynomial fit right there. So then now I need to compute my estimate at x equals 10. So that just requires me to pull out my coefficients. A1 is a star of 2, a2 is a star of 3, and then essentially come back here and grab, whoop, that didn't work. Control C, Control V. So y estimate is A0 plus A1, x, and I'm making it lowercase because x is 10. And then instead of spitting it out, I'm going to plot 10x comma y estimate, and I'm going to do this with a red square. And then I'm going to plot x comma the analytical solution with a blue star. And what I get here is this. Notice that here let's see, the blue star is the analytical solution, which is 1. The red square is my estimate, which it looks like 1.003. Now notice that my red line here is down here. Now the reason for that is because when I computed y tilde, I didn't compute enough data points. So what I really want to do is I want to come back here and recompute h for more data points. So I'm going to go 8, 0.01 to 11 and compute more data points like this. And it doesn't like that because something is the wrong size. Yeah, so I need to do length of x here. Still doesn't like it. Oh yeah, this needs to be transpose. There we go. So now if you notice, my red line is more curved because I used more data points. And now you'll see that the red dashed line and the square are right on top of each other, and then my blue dot is my analytical solution. So notice that my red line goes directly through my given data points, and then let me change my analytical solution to a green star so we differentiate between it. The green star here is my analytical solution, which is slightly different. All right, hopefully that helped you out. I'm just going to scroll through the code slowly so that when you watch this on YouTube, you can see if you missed anything and pause it and whatnot. All right, good luck.